this lesson, you'll learn to identify values excluded from the domain of a rational expression and simplify rational expression. How can a rational expression be used in a movie theater? The intensity I of an image on a movie screen is inversely proportional to the square of the distance d between the projector and the screen. Recall from lesson 12.1 that this can be represented by the equation I equals k over d squared, where k is a constant. The expression k over d squared is an example of a rational expression. A rational expression is an algebraic fraction whose numerator and denominator are polynomials. Because a rational expression involves division, the denominator may not have the value 0. Any values of a variable that result in a denominator of 0 must be excluded from the domain of that variable. These are called excluded values of the rational expression. So first example, they ask us to state the excluded value of 3b minus 2 divided by b plus 7. Well, we just said that the denominator cannot equal 0, and that's going to happen when b equals negative 7. So the excluded value is negative 7. We would say b cannot equal negative 7. Now this is going to be a little bit more interesting because I've got a trinomial in the denominator this time. But as we did earlier in the book, we need to factor the trinomial. So we need factors of negative 12. That'll give us a sum of negative 1. So factors of negative 12 that gives us a sum of negative 1 are going to be negative 4 and positive 3. So the two solutions we would generate would be 4 and negative 3. So I'm going to say that a cannot equal 4 or negative 3 because that will give us division by 0. In the example printed in your textbook, Ken is helping his parents landscape their yard and needs to move some large rocks. And there he used a 6-foot bar and he found he got a mechanical advantage of 5. Said that the mechanical advantage of a lever is L sub b over L sub r, where L sub b is the length of the effort arm and L sub r is the length of the resistance arm. So this time Ken finds he cannot move, since he couldn't remove the rock with the 6-foot bar, he gets an 8-foot bar. This time he places the fulcrum so the effort arm is 6 feet, and so that leaves the resistance arm to be 2 feet long. So if we try that, we're going to have 6 over 2. He gets a mechanical advantage of 3 this time. He had the right idea to get a longer bar, but even though the bar is longer because he moved the fulcrum, he has a mechanical advantage of 3, so he actually has less mechanical advantage than he had before. If Ken applies a force of 180 pounds, what is the greatest weight he can lift with this longer bar positioned as it is? 3 times 180, he could lift 540 pounds. Simplifying rational expressions is similar to simplifying fractions with numbers. To simplify a rational expression, you must eliminate any common factors of the numerator and denominator. To do this, use the greatest common factor. Remember that AB over AC is the same as A over A times B over C, and anything divided by itself, including A's, is 1. So AB over AC is the same as 1 times B over C, or B over C. The greatest common factor of 32 and 4 would be 4. And we can take out an x out of both of them and a y squared. So if I factor out the greatest common factor, what's left is 8x to the 4th, no y, over, and if we take out the greatest common factor out of the denominator, all that I have left is y to the 5th. Anything divided by itself is 1. So my final answer is going to be 8x to the 4th over y to the 5th. We get to factor first. I need factors of 14 to give me a sum of negative 9, so negative 7 and negative 2. factors of negative 35 to give me a sum of negative 2 would be negative 7 and positive 5. Again, anything divided by itself is 1, so I get x minus 2 over x plus 5. When a rational expression is in simplest form, the numerator and denominator have no common factors other than 1 or negative 1. And I'm going to go back a tick here. They didn't ask us to state the excluded values on those two, but on the first problem, I had both an x and a y in the denominator, so I could just add on here x and y do not equal 0. And on the second one, x could not equal 7 or negative 5. Okay, so this time they added the directions that I followed after I saw them to state the excluded values of x, which is always a good idea. Greatest common factor of the numerator is 4, and the denominator I need factors of negative 36 that give me a sum of negative 5. So negative 9 and positive 4 will do the trick. The x plus 4s will cancel out. So I get an answer of 4 divided by x minus 9. And we have to remember to state that x cannot equal negative 4 or positive 9 because both those values will give us division by 0. Summing it all up, we can simplify rational expressions by dividing the numerator and denominator by the greatest common factor, and excluded values are values of a variable that result in a denominator of 0.